there's a new method for radiance field reconstruction that is becoming popular. It is using 3D Gaussians. This is its GitHub repository, and while it comes with its own pretty awesome viewer, sometimes you want something a little bit more scriptable. So what I'm going to show is how to hook up an existing checkpoint that you generated using 3D Gaussian Splatting to a Jupyter notebook and view it interactively. Now, you will need some changes to the default environment, which I have done in my fork. Specifically, you will need Python 3.8, and I have also had poor luck running with 11.6 CUDA toolkits, so I'm using 11.3 here. In addition, you will need to pip install the following dependencies for interactive viewer in the canvas, and also the Kaolin Library. I encourage you to check out the docs for Kaolin Library. Here's the installation docs, and it has lots of cool features. Let's dive right in. So first, just some preliminary imports. Then, assuming that I have already run 3D Gaussian Splat training on some data set, I'm going to load that checkpoint. This is just loading it without argparse. There's nothing really important in this code. So I have loaded my Gaussians and pipeline and also test camera. Now let's render it using the default function and just make sure it looks okay. And it looks just fine, but I can't do anything about it. This is just an image. So the next bit is the code that you actually need, which is converting from the 3D Gaussian Splatting camera conventions to the Kaolin Library camera conventions and back. So I'm going to convert the test camera to Kaolin camera and back and just check that the render looks okay, and it looks fine. Next, let's actually create the interactive viewer. This is all the code that you need. There's nothing really special here. I am just converting the camera, the Kaolin camera to the Gaussian Splatting camera, and then using the default render function. But what I'm able to do now is actually interactively move around my scene, and I can zoom in and zoom out. This is really easy to set up in a Jupyter notebook, and if your checkpoint is remote, your rendering server is remote, you can connect with a Jupyter notebook and just inspect it. But the nice thing about putting it in a notebook is that it's actually pretty easy to configure the viewer and inspect your checkpoint in different ways. So for example, here, let's try and actually filter out which Gaussians we're showing based on their scale. So this is the same render function as before. I'm just going to take a value from a slider and basically filter out all of these Gaussians with a mask and render the same as before. And I'll just create this slider using ipython widgets. So let's give it a try. All right. So I have the same interactive checkpoint here, and I can move around and zoom in and zoom out. But now if I change the slider value, the larger Gaussians are starting to disappear, and finally I'm left with the smallest Gaussians there. This is just one example of what you can do quickly while running on a remote machine, and hopefully you find this useful. Now check out Kaolin Library and other things that it can do for you. Thanks.